And this is our last video for Chapter 1 material. This is the section talking about density, or section 1.10 in your textbook. So let's talk about density. Let's first of all define what density is. Density is the ratio of mass to volume of an object. Oops. So mathematically, we have the density is equal to the mass divided by the volume. Or sometimes, a lot of times it's easy to shorthand this. We just say D, lowercase d for density, and we have M for mass and a capital V for volume. The units that we use in chemistry for density is typically we use grams per milliliter or grams per centimeters cubed. And the relationship between milliliters and centimeters cubed, very easy to remember, and that 1 milliliter is equal to 1 centimeters cubed. This is definitely an equation you're going to want to know. Typically when I put in your notes this know here, I don't like to use the word memorize, but essentially for all intents and purposes you need to memorize this equation. I prefer the term know because as long as you work through a number of examples working with this and you understand the concept, you'll just naturally memorize that equation. You also want to know the units of density and know this conversion between milliliters and centimeters cubed. All right, so there are 3 ways to use density. In other words, there are 3 types of questions that I could ask you regarding regarding density. The first question is the qualitative way that we use density, and that's to determine whether or not something is going to sink or float. So most of you have observed that wood floats on water, but things like rocks or pieces of lead, other metals, sink in water. And that has to do with the density. The density of metals are going to be much, much greater than water, so they're going to sink. Okay? Items that have densities that are smaller than water are going to float. So by looking at their densities, we can determine whether or not something is going to sink or float. The second way that we can use density is to calculate the density. So determining the mass of something and determining the volume of it, dividing those two to get the density. Typically what this is used for, it's a way to identify an unknown. Pure objects have a very specific density that can be published, and there's a table in your book. Again, I didn't look up the change in the number. Let me look at that really quick. Table 13 is what this is now reported as. But there's a number of different densities. You have densities of your solids, densities of liquids, particularly your water here. Very important for us is the density is 1 gram per milliliter. And then you have your density of gases, which, because gases are so not very dense, they are actually usually given in grams per liter instead of grams per milliliter. Looking at, going back to this, determine whether or not objects will sink or float. This picture from your book, which is figure 11, basically is what we're talking about. So instead of a piece of wood, they have a piece of cork here. Okay, this is the liquid here is water. Down in the bottom we have lead and a piece of aluminum. Looks like aluminum foil there. Aluminum has a density of 2.7 grams per milliliter, lead at 11.3. So these are more dense than water, which is why they sink. We have solid water here. Our chunk of ice has a density of 0.92 grams per milliliter, which is less than 1, but it's not so less. So that's why kind of sometimes your ice cubes can, they don't always necessarily go straight to the top. They don't float on the water. They kind of sink a little bit, and they can be in between. And it's because they have very similar densities. The cork has a density of 0.26 grams per milliliter, so that's much lighter, much less than our density of water at 1 gram per milliliter, which is why it floats. All right, I'll tape those in once I get done with this. Here are 3 ways to determine density. Okay. To calculate density, we'll do an example of that momentarily. Okay. So stay tuned for how to do that, or different methods to determining our density. The third way to use our density, okay, we have 2 different units here, something per something for our density. Whenever we have something per something, we can use that as a conversion factor. So remember I said when we covered that the section 1.9, our problem solving section, is that it was really critical to get those under your belt, because throughout the quarter, all I'm going to be doing is giving you new conversion factors to work with. So we haven't even left chapter 1 and I'm already giving you a new conversion factor. So this conversion factor is different than the ones that you've been working with, and that's because it mixes the different types of measurements. Okay. In section 1.9, all of the conversions that you did were between a mass and a mass, so say kilograms to grams, or a length to a length, going from feet to yards, yards to meters. Those were all the same type of measurement. Now for this conversion factor, this one allows you to convert between 2 different types of measurements, between mass and volume. So typically what you're looking at, you're being able to convert between grams and milliliters. So again, we'll do an example of this after we do an example calculating our density. So let's see. I'm going to tape these into our notes so our notes are nice and complete for us. All right, so let's work through an example of calculating our density. Oops. So we have the mass of a solid object is 88.25 grams, and it displaces 7.6 milliliters of water. And what is the identity of the object? So remember when I said we can calculate density? We can do that in order to identify an unknown. Okay? So basically in this question, what we're doing is we want to calculate our density. So we have the mass of our object. Okay? So we know that density is equal to our mass divided by our volume. Okay? And we know our mass we're given is 88.25 grams. And the volume of our object, okay, is going to be 7.6 milliliters. So what it means by when it says this object displaces 7.6 milliliters of water, that's determined by what's called the volume displacement method. So basically, if we wanted to do this in a lab setting, okay, if we were collecting these values, basically you can get the mass of your object by sticking it on a balance. Okay, so this is telling us the mass of a zinc object. This isn't our example, but that's where we're going to get our mass, is by sticking it on a balance. Okay. This volume displacement comes from taking, this is called a graduated cylinder. It's a piece of glassware that we use in a chemistry lab. Okay. And we have a certain volume of water that we put in there. Okay, so this we would have our initial volume. Okay. Then we'd take our piece of metal, okay, put it into that graduated cylinder, and that's going to displace however much volume this piece of object has. It's going to displace that amount of water. So we'll have our final volume. So to determine our volume of our object, we take our final volume, so V final minus V initial, and that's going to get us the V, the volume of our object. This is called the volume displacement method. So volume displacement. Very common, easy way to determine the volume of our object. So we already know that if we did this volume displacement, we would have a displacement of 7.6 milliliters. So we can then plug these two values in. They're in the correct units. So we're going to plug them into our equation here. So density is going to be equal to 88.25 grams per 7.6 milliliters. We plug this into our calculator. And we get 11.6118. That's probably enough values there. That's grams per milliliter. Remember, our last step to any calculation is we want to look at our Sig Figs. We're dividing these values, so we want to look to the lowest number of Sig Figs. Our first value we have, this has 4 Sig Figs. Our mass. Our volume has 2 Sig Figs. So our final answer, we want to 2 Sig Figs. So my 1 and my 1 are significant. We have to round up because we have a 6 next door. So my final answer is going to be 12 grams per milliliter. So I want to use this density to try and figure out what the object was. Okay, a great way to start is to look at your table of your densities. And we know we're looking at a solid object, so I'm going to look in my solids. And really the only thing that's close there is the lead, which has 11.3 as its density. Okay. Now remember, for this value, mathematically 11.3 and 12 aren't the same, but remember our degree of uncertainty is in that 2. So that can kind of range. So an appropriate identity of this unknown object really could be lead. Now, there are lots of other objects out there that have densities around 12 grams per milliliter, so it's possible this isn't lead, but given the table that we have from the book, this would be an okay assumption, or, these densities were given. Of what was given, this solid object could be lead. So that's an example of using density to calculate the density and identify an unknown. The next example, what I want to do is show you how to use density as a conversion factor. So how many liters of ethanol, otherwise known as ethyl alcohol, those are the same chemicals there, contain 1.5 kilograms of alcohol? So we're going to start with something we're given. We're going to start with our 1.5 kilograms. And we're going to want to eventually calculate to how many liters. Now, anytime that we see we're starting with a mass, we're ending with a volume, we know we're going to use density. Okay, that's what we have to work with. So our density of our ethanol, so I have D, and then I put ethanol as a subscript to that. We can look up in our table here. We have ethyl alcohol, and it has a density of 0.79 grams per milliliter. So our density of our ethanol, we have 0.79 grams per milliliter. So as long as we can somehow get our mass from kilograms to grams, we can then convert from grams to milliliters using density. And then we have liters and base unit of liters and liters, so we can convert that. So kind of our plan of action of what we're going to do for this is we want to convert from kilograms to grams. And to do that, that's going to be a metric conversion. So for help on that, consult section 1.7, 1.8, and 1.9 to convert from kilograms to grams. Then our new conversion with this section, we're going to go from grams to milliliters. And that's where we're going to use density. And then our final conversion, I'm just going to make my arrow really big here. Okay. That's, again, another metric conversion. So when I start having kind of big conversion factors or big problems of converting a lot of units, I like to kind of map out how my calculation's going to go. And I usually do that by putting my units there with arrows, okay, saying I'm converting from kilograms to grams, then grams to milliliters, then milliliters to liters. And I like to put above the arrows kind of what conversion factor am I using? Where am I getting this information to complete that conversion? So you'll see this arrow kind of planned out question a lot from me. All right, so we have 1.5 kilograms. I'm going to set up our railroad. First conversion is to go from kilograms to grams. So we want to go kilograms in the denominator, grams up top. Put kilograms down in the denominator so those units cancel out. Now remember, when we convert with metric, we put the 1 with the prefix, then the meaning of the prefix or the value goes in the other. So we have 1 kilogram, 10 to the 3 grams. My next conversion is to go from grams to milliliters. So I have grams in the denominator so that those cancel. Put milliliters up top. And if I forget what conversion factor I'm using here, we just look up to our plan of attack here. I know I need to use density. Okay, and we'd looked that up. So we know the density of ethanol is 0.79 grams per how many milliliters? Per 1. So remember, whenever we have that multiple units, the bottom unit already has 1 with it. So we have 0.79 stays with the grams. And then we have 1 milliliter goes up top. Now our final conversion, we want to convert from milliliters to liters using our metric conversion. So our 1 goes with the prefix, so 1 milliliter. Milli means 10 to the negative 3, so we put that up top. And now we're ready to do our calculation. So, remember, I'm going to zigzag. I'm going to multiply across, divide down. Okay, so I have 1.5. I'm going to multiply by 10 to the 3, okay, for my grams. Divide by 1, which we don't have to do. Anything divided by 1 is still self. Multiply by 1, same thing. Divide by 0.79. Multiply by 10 to the negative 3. And divide by 1. So my calculator spits out, I have 1.8987. So I have 1.8987. My units are liters. Am I done with my question? Have I written my answer down correctly? The answer is no. Hopefully you're yelling at your screen. Significant figures. Remember, that's always our last step, is to check our Sig Figs. Okay, we want to start with and look at the value that we started our calculation with for our Sig Figs. So I have my 1 and my 5. So I have 2 Sig Figs that I need in my answer. So my 1 and my 8 are significant. So I want to rewrite this to 1.9 liters. Now for our full explanation of our Sig Figs, in case you run across it in the sapling learning, okay, remember, I take Sig Figs off the value that you start with. Technically, you should consider all of the Sig Figs for all of your calculations. Sapling is a little bit not wishy-washy, but lenient on their Sig Figs unless they're specifically asking about Sig Figs. Again, if you run into any problems with that or questions, please don't hesitate to contact me. post something to discussion forum, text me, email me. I don't need any confusion out there. So if you guys have any questions, please don't hesitate to ask. Okay? But just in case you run across it, our two metric conversions, these are infinite sig figs, okay, because they are exact, they are ratios. Okay. Density technically is a measured value. Okay, so this actually has two sig figs to it, the 7 and the 9. But as usual, what happens, even if you have significant figures in a conversion factor, it doesn't affect your answer because your value that you started with is usually what you're going to go with anyways. So in this case, we did it correctly, 2 sig figs, 2 sig figs. We needed 2 sig figs in the end. So that ends our discussion, our lectures on Chapter 1. Okay, you want to make sure that you work through a lot of problems, especially for Section 1.9. Also work with density. Work through your QMP. There's QMP at the end of the chapter as well, which are good questions to make sure that you mastered the topics throughout the entire chapter. Work through the Sapling Online questions that are available to you. And then once you feel you are confident and ready to go ahead and take the homework quiz for Chapter 1, which is going to put all of Chapter 1 into one quiz there for you. And then don't forget we have an entire exam devoted to Chapter 1. So also want to take that, and that is located on Moodle. Okay. If you have any questions, please don't feel afraid to ask. Post something to the discussion forum. If you're a student who this makes super sense to you, go ahead and help your fellow students out and respond to things on the forum. Help your fellow classmates out. You can also email me or send me texts, and I can answer those. If there are questions that you would like worked out to see on video, I can make those for you. Just let me know and I can get those posted. Otherwise, just really your best friend to understanding this material is to work through as many problems as possible.